Okay, hello everyone. Let us now proceed to polynomial functions of higher degree. So what we're going to do in this lesson is we're going to observe different graphs of different functions, and then we're going to look at its end behavior, and then the last part will be trying to determine the polynomial function given this graph. Okay, so let's start with the first one. Okay, we have the zeros. We're going to take a look at the zeros, degree, multiplicities, and leading coefficient. Okay, so we have here the equation on the top right, so that it's just for reference. Okay, so what we really want to do here is to determine the zeros, degree, multiplicities uh, given this graph. Okay, so start with the zeros. So if you're given the equation, how do you determine the zeros? So you determine the zeros by by solving the equation, right? If y is equal to 0, right? So essentially we are finding the x-intercepts. So we set y is equal to 0. So in this case, we have x plus 2 squared, x minus 1 is equal to 0. So x plus 2 multiplied by x plus 2 times x minus 1 is equal to 0. So you're basically, then we apply the zero product property. So then we get x is equal to negative 2 is x equal to negative 2, and x is equal to 1. As you can see here, you have here um, x is equal to 2 with the multiplicity of 2, and x equal to 1 with the multiplicity of 1. As you can see here, we have the roots on the graph. We have negative 2, 0, and 1, 0. Okay, so these zeros right here on the graph will help us in determining what the factors are of our polynomial function. Okay, so that is a very big help in determining the equation. Okay, so what we're going to do is reverse. So if you have if you're given the graph, so what you're going to do is you write y is equal to the factors given your zeros. If you're given negative 2, so that would mean the factor is x plus 2, right? So and then if you're given 1, 0, so that would be x minus 1. Okay, so from the example that we did just earlier. Okay, so now the problem is how do you determine the multiplicity? Okay, so as you can see here, squared, the multiplicity is 2, and the multiplicity of x minus 1 is 1. Okay, so how do you determine the multiplicity so that you can get the correct polynomial function? Okay, so before that, let us go to the degree first. So we are done with zeros. So let's take a look at the degree. How do we determine the degree from the graph only? So we can determine the degree by taking a look at the number of turning points. So what are turning points? So turning points are the points in the graph where the graph changes from increasing to decreasing. Okay, so this is a turning point. Negative 2, 0 is a turning point. And then what are other turning points? We have here 0, negative 4, which also happens to be the y-intercept. So it changes from decreasing to increasing. Okay, so that's also a turning point. Okay, so if the graph has a degree of n, then the number of turning points is n minus 1. Okay, since we have in this particular graph, we have 2 turning points, then our n will be 3. Okay, so we will have a degree of 3. Okay, so another way to determine the degree of a graph is by passing a line throughout the graph. So example, if you pass a line here, so you can intersect a line to the graph at the maximum of n. It will intersect the graph at the maximum of n points. Okay, so if your line intersects your graph at the maximum of 3 points, then your degree is 3. Okay, so that's also another way of determining the degree. Okay, so there are two ways. So now that we know how to determine the degree, we can now then um, apply that to determine the multiplicity. Okay, so let's write the polynomial function again that we've arrived at earlier. So now that we know that our degree is, our n is equal to 3, right? So how do we know where to put the squared? So do we put it in x minus 1 or here, x minus 2? How do we determine it from the graph? Okay, so as it turns out, so we have to remember this. If the graph, you have to take a look at the zeros. If at that particular zero, the graph just touches that point, so touches meaning the behavior is like this. So it just goes to that point and then it changes trajectory. So it just touches the point. So that the you know that the multiplicity of this root is even. Okay, and if the graph passes through it, if it crosses through that zero, it crosses through here, right? So you know that the multiplicity of that root is odd. Okay, so now given that the x plus 2 has to be even and the multiplicity of x minus 1 has to be odd, then how do you distribute the 3? So you only have 3. So therefore, x plus 2 should be the 2 and x minus 1 should be the 1, right? That's how you determine the multiplicity. Okay, so yeah, you have it here. Then what about the leading coefficient? Okay, so what about the leading coefficient? So how are you going to determine that? So you're going to determine the leading coefficient by using another point. You have here the y-intercept. Oh, sorry. So you have here the y-intercept. So the leading coefficient is actually the general. The general form of the factored form is actually y is equal to x minus x1. So these are the zeros, or x minus x2. So to x minus xn. Okay, and we have different multiplicities here, and then we have a here. So this is the leading coefficient, and in this form, this is also this is also our stretch factor. Okay, so how do we determine this? So the way to determine this is to use another point. So in this case, in the first graph, we can substitute 0, -4 into our equation. So you actually have to write a here because it is always present in any factored form or in any polynomial function. So in factored form, this is the general form. So y is equal to a multiplied by the factors and its multiplicities. So you can determine this a by substituting 0, -4 to it. Okay, so that's basically how you determine the graph. The equation of a certain polynomial function given its graph. Okay, let us now take a look at other graphs. So we have right here another graph. It is of degree 4. So how do we determine its degree again? So we will determine the degree by looking at the number of turning points. So how many turning points does this graph have? So we have 1, 2, 3. So it has n minus 1 is equal to 3. Therefore, the number of turning points is 4. Okay? So we can also pass a line. So let's say pass a line here. So what is the maximum number of um, intersections of the graph that we can find by intersecting a line? So we can find 4 intersections. So that is also another way of determining the degree. So the degree is 4. Okay. So now that we know that the degree is 4, right? So n is equal to 4. Very cool. So now let's take a look at the zeros. So if we take a look at the zeros, we have a -2, 0 here, we have -1, 0, and 1, 0. So that explains the different factors that we have here, right? X plus 2, x minus 1, and x plus 1. So what about the multiplicities? So as you can see here, in -2, 0, it just touches, the graph just touches that point. So therefore, we have an even multiplicity. And then for x plus 1, we have here -1, 0. So you have a 1 multiplicity here because it crosses. And then another one is this one right here, 1, 0. So you have another 1 multiplicity right there. So a total of degree of 4. Okay, so that makes sense also. Now, in order to determine this stretch factor right here, we have 1/2. So we just have to substitute the just need to substitute the this point to our preliminary equation that we can derive. Okay, so let's proceed.